empirical formula mass. And the empirical formula mass is just determined by, let's say the empirical formula is over here, CH. Yeah, so the empirical formula mass is just the mass of one carbon plus one hydrogen. So that's 13.02. Now, the molar mass is always given in an exam. It's always given. And the empirical formula mass, it's determined from the EF, as we said before. So they give you the molar mass of, for example, benzene. And then all you have to do is divide the molar masses given by the empirical formula mass, and you get this value x that you need to multiply by. An example of this question is, for example, determine the molecular formula of a compound with molar mass 56 grams per mole and empirical formula of CH2. Now, they wouldn't likely give you the empirical formula. They'll probably ask you to calculate it in the previous question, and then using the empirical formula that you calculated, you'd find the molecular formula. But the way you do it is you'd say that the mass of CH2 is just one carbon and two hydrogens, which is 14.03. And then you find x by dividing 56, which is the molar mass of the compound that was given, by 14.03, and you get approximately 4. So what you do is you multiply the ratio 1 to 2 by 4 on each sides, and you get the molecular formula C4H8. Now, another style of question that you might get, and you would probably get, you might not get the previous question, but you will probably get either this question or a question we'll see later on, which is calculating the empirical and molecular formulae of a hydrocarbon from the experimental data of complete combustion. Now, what do we know about complete combustion? We know that when hydrocarbons undergo complete combustion, they react with excess O2 to form CO2 and H2O, and these are the only products. Now, in the exam, they will give you info, or they probably will, unless you already don't have it, on the mass of CO2 produced from this reaction, the mass of H2O produced from this reaction, and the molar mass of the hydrocarbon used. This is used to find the molecular formula, which we'll use later on. However, these two are important for finding the empirical formula. So if we take a look at the amount of mass of CO2 produced, we can find the amount of moles of CO2 produced by just dividing the amount of mass by the molar mass of CO2, which is 44.01. And from that, we get the moles of CO2. Now, if we look at CO2, if we look at the formula for CO2, the ratio between the amount of moles of carbon and the amount of moles of CO2 is 1 to 1, since there's only one carbon in one CO2 molecule. That means that we have to multiply by 1. But no, we don't have to multiply by 1. It's just the same. However, this is just a representation. The amount of moles of CO2 is the same as the amount of moles of carbon. And since the only part of the reactants with carbon in it is the hydrocarbon, if we find the amount of moles of carbon here, it's the same as the amount of moles of carbon here. So now actually we have the amount of moles of carbon in the hydrocarbon. And we can do the exact same thing with the hydrogen from H2O, since there's only hydrogen in the reactants in the hydrocarbon, and there's only hydrogen in the products in the H2O. That means that the amount of moles of hydrogen in the H2O is the same as the amount of moles of hydrogen in the hydrocarbon. So we do the same. We take the mass of H2O, we divide it by the molar mass of H2O, which is 18.02, and we need to multiply by 2, because here it shows that in one molecule of H2O, there's two atoms of hydrogen. So we need to multiply the amount of moles of H2O by 2, because for every one H2O, there's 2 hydrogens. And then we get the amount of moles of hydrogen. Now, all we need to do, this is the final step, we need to simplify the ratio between NC, the number of moles of carbon, and NH, the amount of moles of hydrogen, to get the empirical formula. So let's say, for example, this value we got was 3, and then this value we got was 9. Then we'd simplify it, we divide both sides by 3, and we get a 1 to 3 ratio. Now, that itself is the empirical formula. If the question's asking us to find the molecular formula, we can use the mass of the empirical formula. So let's say it was CH3, as we said before. The mass would be 15.04, and using that mass and the molar mass of CXHY, which is always given in the question, we can determine the molecular formula by using this handy formula here, and we just times the multiplying factor x by the ratio in the empirical formula. Now here's just a practice question for the style of question that we just talked about before. So the question reads, after combustion with excess oxygen, 38.196 grams of a petroleum compound with a molar mass of 216.510 grams per mole produced 38.196 grams of carbon dioxide and 18.752 grams of water. A previous analysis determined that the compound does not contain oxygen. Find the molecular formula of the petroleum compound. So since the goal is to find the molecular formula, we need to not only find the empirical formula first, but later on find the molecular formula from the empirical. So the information that we know here is that it went through combustion with excess oxygen. So it's a reaction of complete combustion, which we determine here by this equation. And we also know that the molar mass is 216.510 grams per mole. And that's used to find the molecular formula. And then it produced 38.196 grams of carbon dioxide. So we have MCO2, and we have MH2O, 18.752. And this is an important note that you'll understand later on. But now we know that the hydrocarbon itself, the compound, sorry, the petroleum compound, doesn't contain oxygen. So we know that it's only carbon and hydrogen. And it tells us to find the molecular formula. So first we write out the equation, and then we write down the information that we know. We know the molar mass, the MCO2, and MH2O. And then we undergo the same process as before. We find NCO2, which we get is 0.868 moles, and we know that it's the same as NC. Then we do the same thing with NH2O, and we multiply by 2. Don't forget, multiply by 2 because of the ratio of H to H2O. And you get the number of moles of hydrogen as 2.082 moles. Now, all you need to do is just find a ratio between the two, and then just simplify the ratio. And here, another thing is the key that I gave you last time. It's just for the most common cases. However, sometimes you'll get a case like, for example, 1 to approximately 2.4. Yeah, and you know that if what number do we need to multiply 2.4 by to get an integer? Now, you can't really round up to 2.5 because like even 0.1 is significant unless it's 2.9 or 1.1, or sorry, 1.9 or 1.1. You can't really round up. It's the safest way here, and you won't get marked down in an exam. It'll probably be an error carry forward mark if you get a wrong